Hey guys, welcome back to another video from Smart Interviews. So today we're going to discuss the problems under CodeChef Contest Starters 136 in Division 3. I am Sanjay Kumar. Let's get started. Let us start with the first problem, even sum summary. So you're given an array A of size n. Find the size of largest subarray of A which has even sum. So that means you're supposed to find the largest length of the particular subarray with even sum. Look, if you look at the constraints, 1 less than or equals to n less than or equals to 50. So that means obviously you can go with a very brute force solution, that is, why can't we just simply generate all the subarrays and each and every subarray get the sum, and if that particular sum, if that is even, you can simply consider the maximum of all these sums. Yes, so this is one way, and we should also do in different way. So let us take an example. Let us take this example 22112. So obviously multiple ways are possible. 22112. Okay. So the approach is something like very simple. So if we want the largest subarray, so obviously if you take some example like this, if this particular length of subarray, let us say this particular length of subarray is having even sum. So if this is having even sum, what if you can simply add a number that is once again even? Yes. So if this is even as well as this is even, obviously the next time you're going to say this entire subarray is having even sum. Yes, and obviously you're going to consider this entire subarray because it is having more length compared to the previous, in the very straightforward logic. So this is what we are going to use. And once again, the other thing is like, if this particular part, until this particular part, if you got something like odd sum, so if this is until this particular part, if it is odd, as well as at this particular point if it is once again odd, what does it actually indicates? Yes, what does it actually indicates? Something like something was added until this particular part, and the elements which are present in between are definitely giving you the even sum. Yes, because of this even sum, some odd plus even is going to be odd. So the logic I'm going to say here is something like even plus even will always be even. Yes, odd plus some even will also always give you odd. So obviously if you want to perform this kind of operation, what I'm going to do, I'm going to get prefix sum for this entire. So prefix array, I'm going to populate prefix sum array for this particular array. So it's going to be 2, this is going to be 4, this is going to be 5, 6 and 8. Yes, so for this particular subarray, what is going to be the maximum length? What is going to be the answer for this particular subarray? Yes, so answer here is going to be 4, and if you look at the explanation, the largest subarray is going to be 2211 having size of 4. So if you consider this, this is not going to, yeah. So until this particular part, if you take this entire subarray, this is going to be the largest part. But based on the input is given something like one more one is present here as well as 2. Yeah. So based on this, we get 7 as well as 9. So obviously, as I discussed, so the largest is going to be from this particular part to this particular part. So how could you get this? Yes, how could you get this? So as we're just simply moving on with prefix sum. So at some particular point, if you got some even sum, can I just simply start saying that maybe this is one particular possible subarray starting from 0th index to that particular point, which is having even sum? Yes. So while you're populating this, or else after populating this entire prefix sum array, at a particular point, if you have encountered some value that is even and that is to the rightmost end, you can simply consider that value. Maybe this could be part of our answer, so you can simply include this. And also one more thing, as I discussed, this is one case and this is the second case, right? So we are done with the first case and we are supposed to discuss the second case. So if you want here, I want something to be at that part, to the particular part, that is going to be odd, and some even added to this, so you're going to get once again odd. So if you want to discuss some kind of this, you can simply take this particular thing, because at this point the sum is odd, and at this point once again the sum is odd. So if you see here, in between the elements which are being added, the elements which are being added are always going to give you the even sum. Yes, so if you see here 1 plus 1, that is going to be even sum. So because of which we are going to get the evens like odd and once again the odd. Yes, and if you also can include this particular number, the entire thing that is going to give you the even sum. So because of which you're going to get odd value once again. Yes, so this is the second case as we discussed. Out of these two, we're going to return the maximum. So obviously, if we are supposed to find what is the first occurrence of odd element like odd sum, and what is the last occurrence of odd sum, and obviously if you want the difference, because this is not inclusive, right? This is not inclusive, you're going to say, let us say if it is a and this is b, you're going to say b minus a. You're going to say b minus a is the length of the particular subarray with even sum. Yeah, this is the one thing that you're going to do. So let us start coding for this. So this is all taking the input for each and every test case. You're going to read the entire array, and let us say you're calling this function largest even sum subarray. And for this subarray, let us try to implement this entire logic. Yeah. So firstly, what all things we are required of? Let us say we are required of some int sum. I'm going to take the entire array. So let us say prefix sum equals to new int of size n. So after this, we are going to iterate on the entire array. So for int I equals to 0, so I less than n, I plus plus. So what I'm supposed to do? I'm supposed to add each and every value to this prefix sum. So let us first say sum equals to 0. So you're going to say h plus equals to, this is something like lst of I, prefix sum of I is going to be s. So with this, you're going to populate the entire prefix sum. So after populating this prefix sum, what you're supposed to do? You're supposed to search for the largest subarray with even sum. That means if you can simply get the rightmost occurrence of even sum in this prefix sum, you're going to get the first case. So for this, I'm going to say for int I equals, I'm just iterating from backwards, n minus 1, I greater than or equals to 0, I minus minus. So what I'm supposed to do here, if prefix sum of I, if that mod 2, if that is equals to 0, yes, that means you're going to get the subarray starting from 0th index to that particular index which is having even sum. Yes, maybe this could be our answer. So if this is our answer, what we are supposed to do, let us take our answer int answer equals to 0, the very start. Here I am going to say answer equals to math dot max of answer comma, what is this, ith index. So if it is ith index, the entire subarray is going to be I plus 1, I plus 1, and I'm not required to even go further. I'm going to break this. Yes, this is one thing. So with which you're going to get the largest subarray with starting from 0th index which is having even length. So after this this is done with the entire first case. You're supposed to go with the case number 2. So for this case, you're supposed to get the first occurrence of odd sum as well as the last occurrence of odd sum. So let us just simply say int last equals to 0 as well as int First is going to be 0, semicolon for both of them. Yeah, so I'm having last as well as I'm having first, so I'm supposed to calculate this. So let us say I'm once again iterating in, let me just simply copy this better. For last I'm performing this, as well as for first I'm once again supposed to perform this. So I'm going to start from 0, I is less than n, I plus plus. So what I'm supposed to do, if prefix sum of I mod 2, if that is not equals to 0, I'm going to say first equals to I. Yes, that means you're going to get the first element. And for here, I'm going to say the exact same thing. If prefix sum of I mod, if that is not equals to 0, I'm going to say last equal is going to be I. So if you see here, uh, if this is 0th index, first, second, third, fourth, fifth. So if I can somehow point my A value to 2 and somehow point my B value to 5, I'm going to say the length of largest subarray with even sum with this particular range is going to be this, and that is going to be B minus A. Yes. So finally I'm going to say at last, I'm done with first and last. I'm going to say answer is going to be math dot max of answer comma last minus first. FAR, let's take first. So this is what I'm going to get this as answer. I'm going to return this. Return answer. I hope the logic is clear. Once we got this, we are not at all required to even go further. Let us break it here. Break it. You're going to get first and last. You're going to return this. And in this, I'm just calling this. I'm going to return this. So I'm going to print this. Okay, expected a semicolon. Missing else. So we got some output. Let us compare with the input and output. So 1340, yes, 1340. Let us update this. Yeah, the test cases, all the test cases got passed. Yes, moving to the next problem, my first geometry problem. You're on a 2D grid where you start at 0, comma 0. You're given a binary string s of length 4, where s1 refers like only it is of length 4. So s1 actually indicates s of 0 refers to left direction, s2 to the right direction, up direction as well as the down direction. S of I is equals to 1 denotes that you are allowed to make a move in that respective direction and vice versa. Okay. Find the number of cells x comma y you can possibly visit which satisfies the condition saying that it should be in the less than or equals to 10, like in the range of less than or equals to 10 as or else greater or equals to minus 10. You're also given a note that you always include the cell 0 0 in your answer. So obviously if you have some answer, you're supposed to include always 0 0 in your answer. If you can visit a comma b like a1 b1 and a2 b2 individually but not both at the same time, you will still include both of them in your answer. Okay, moves are defined as a move in left direction is going to be, so this is the way you're going to move. So input format is given as well as the constraints. So s contains only 0 or 1 because it is a binary string, and length of s is going to be 4, that is for sure. Si is going to be 1 for at least 1. Obviously, for at least one of the integer, so phi is going to be 1 for sure. Okay, let us go with the like examples. First example is going to be 0010. So if it is 0010, the output is 11. Okay, it is 1100, your output is 21. Let us see. So 0010. So 0010. So it was mentioned like I guess left, right, up, down. Let us see once. Left, right, up, down. Yes, left, right, up, down. So this is the way you are supposed to follow. Yeah. So this is of left, this is of right, this is of up, and this is of down. So that means you're only allowed to move up, and from particular point 0, 0, you're only allowed to move up. You cannot move down, or else you cannot move left, or else right. So as you are at 0, 0, as you're at 0, 0. So firstly it was mentioned like you're also supposed to include this 0, 0 in your answer. So let us first say answer is going to be 1. As you're supposed to only go move up. So in one step where you're going to move. So this is the first step, right? Yes. So if it is 0, 0, this is going to be so as it was mentioned. So if it is up step, you're going to move from A to B, sorry, A to A B plus 1, something of this form, A B plus 1. So it is going to be 0, 1, and in the next step you're going to move to 0, 2, once again to 0, 3, and so on, so on, so on, till 0, 10, because it was mentioned only in the range of -10 to 10. So if you want how many number of ways, like how many steps I have reached until 0, 1, it's going to be 1, as well as also going to include this 0, you're going to say it is going to be 2. In the same manner, until 10 it is going to be 10. Also, if you try to include this 0, you're going to get 11. So output for this example should be 11. So let us look at that. Yes, for the first example we got output as 11. Yes, let us take the second example, 1100. So 1100. So you're allowed to move either left or else right. So that means you are at 0, 0. You are at 0, 0. Firstly, you're moving left. You're moving left. Yes, this is one way possible. You can also move towards right. Yes, this is one other way. Yeah. So you have reached, this is one cell, this is second cell, and this is third cell. Yes. Moving further, from this particular cell, you can once again make the two direction ones. Either you could move left or else move right. So this is going to be fourth cell, but when you move, let me take a different color. You can move towards left or else you can move towards right. So when you move to this particular part, you can simply say this is the fourth move. But when you move to the back, this cell which is already being visited, do we need to also include this? May not. So you're not going to include this because this is already taken by this step, first step. So this is the way you're going to get. So as I can simply assume this is 0, 0, this is going to be 1, 0. Yes, is going to be 2, 0, something of this format. Yes, and in the same manner, so as you're going left, so this is not going to be 1, 0, this is going to be -1 comma 0, and this is going to be -2 comma 0. In the same way, if you're going towards the right, this is going to be from this part you have two options, either go to right or else to left. It's already taken, that is 0, 0. You're going to say this is 1, 0, and this is going to be 2, 0, something of this format. So until 10 comma 0 you're going to traverse, until -10 comma 0 you're going to traverse. So overall how many number of that you're going to get? So if you see 21, so as we just simply see here, 10 on the left, 10 on the right, plus this 0, you're going to get 20 plus 1, that is going to be 21. So this is the way you got the answer, that is 21. But things get complex when you have something like 0, 1, 1, 0, you're going to get 121, because so if you see here 0, 1, 1, 0, 0, 1, 1, 0, so that is going to be right move as well as the up move. So if you're starting with 0, 0, you can either take a rightmost move or else the top move. Yes, the top move. So from this part, once again, you can either take right or else top. Yes, and from this, once again, you can take right or else top. So you're going to explore on the entire part until 10 comma 10, I guess. Yeah. So this is going to be 0 0. So this entire part you're going to traverse. If I can simply assume this is the last index 10 comma 10. So with this you're going to get some value that is going to be that is was given as 121. So we did not figure out here. So some value you're going to get, you're going to take that particular value. Yeah. So try to hard code the values based on the input is somewhat complex, because if we can somehow figure out in the first case itself, we can simplicate. But if we can somehow not able to figure out that, that will be complex, right? So for this reason, let us think of a different logic. Let us say you're starting at this particular point. Yes. So when you're supposed to consider this particular new cell, yes, only if it is not visited. Yes, only if it is not visited. And when you're going to consider this particular cell, only if it is not visited. So it is making more sense that if it is not visited, you're going to consider, or else you're not going to consider. So only consider if not visited. If not visited, so that means we are supposed to keep track of some visited part, that means which you have already visited. Yes, so this is something we are required of, as well as some kind of traversal that you're going to perform on this, so that you're going to get all the number of non-visited as well as you're going to mark them as visited. So what kind of traversal technique that we're going to use? Obviously we can simply use a BFS. Yes, we can simply use a BFS. So let us try to convert the logic that we got into code. Or else let us discuss the logic first. Something like, in more sense, the logic is going to be something like, if you have started with zero, if you have an above move, that means if you can simply move up, one step up, I'm going to move to one step up and add it to my visited, and I increase my answer to be one. Yes, if it is not visited, only if it is not visited. The very general BFS. Okay, let us go to the code. Okay, let us code it up. Let us say I have written all the test cases. I have written the string s. I'm going to call this function possible cells visit, or else count of possible cells visit. Let me copy this, paste it here. Yeah. So for this function, what I'm supposed to do? So if you look at the input ones, you're going to get this particular string. For each and every string, we are supposed to traverse, and this string is of only length 4. Yes, that is making sense. This is of length 4. So first, let us take the directions. What all directions we actually have. So let us take directions is going to be an array, and what all things that you're going to take. Either you can move left. So if you're moving left from a comma b, it is going to be a minus 1 comma b. So can I just simply say minus 1 comma 0 is going to be one thing here. If you're moving right, it is going to be 1 comma 0, as well as if you're moving up, it is going to be 0 comma 1. Okay, let me mention parentheses. And what is the other thing that is left over? Going one step down. So if it is one step down, it is going to be 0 comma minus 1. So we got all the directions. So from this direction, what we're supposed to do? We are supposed to simply traverse on each and every string, that is the entire string, like it is of length 4 for sure. So while traversing, if it is set bit at a particular position, I'm going to include that particular direction. Okay. Um, Let us also take one other thing like directions to be traversed. I'm going to take an empty array that is directions to be traversed. So when I can simply get the particular string of I, if that is one, I'm going to include this. So I'm going to say for okay, find range of for if s of I, if that is 1, what I'm supposed to do? If that is a set bit, that is a set bit, I'm having a possible direction moving that particular way. So I'm going to include directions to be traversed dot append of what I'm supposed to append, directions of that ith direction. So if the fourth bit is set, you're going to include this into your directions to be traversed array. So finally you're going to get all the directions in which you're supposed to traverse. And it was also mentioned like you're presented starting at 0 0. So as you're present at 0 0, let us take a queue in simple array. You started at 0 0. Let me also take some answer that you're going to return. Finally, you're going to take q, and while you're applying BFS, how you're going to apply? So while this queue is not empty, you're going to traverse on each and everything, and you're going to append like add the new things into the queue. So while queue, what you're supposed to, while queue is not empty, you're supposed to pop the first element, that is the zeroth element. Okay, how can I pop this? Let us say are we required of this particular element? Yes, we are required. So let us take something like at this particular row and at this particular column we are present. So let us say row comma column equals to q dot pop 0. So you're going to pop this particular element and that you're going to store in row comma column. So after this, we're having this row and column. If this row and column, if it is not visited, you're going to add it to your answer, or else if you're not going to add it, you're going to say if. So obviously we require of this row comma column. So if you want to check in some set, obviously like some set is required to check whether it is visited or not. Let us say visited equals to a set that we're going to take if visited of this particular thing, row comma column, or else something like we can simply check if row comma column is visited, uh, row comma column in visited. If it is present, what we're supposed to do? Do we need to add it to my answer? No, I'm not at all required. I'm supposed to simply continue. But if it is not visited, what I'm supposed to do? Simply increment my answer plus equals to 1. I've simply incremented my answer. Then after, I need to mark it as visited dot add. I'm going to add this into my visited, something like row comma column. Then after, I'm supposed to traverse in that particular direction on all the directions from this particular point. Yes, so starting from 0, I'm present at 0 0. I'm going to say like while queue is not empty, row you're going to get row comma column. Firstly 0 0 is not present in visited, you're going to add 1 to your answer, and you're going to add 0 0 into your answer. After adding 0 0 into your answer, you're supposed to traverse in all the directions in which you're supposed to traverse, directions to be traversed. You're going to traverse on the directions to be traversed. So how can we do this? For let us say x comma y in directions to be traversed. So what I'm going to do here, new row is going to be x plus the previous row what we got, and new column is going to be the value of y that we're going to add plus the previous column that we are already present. So we got this row and column. So if we got this row and column, we are supposed to add it into my queue. So firstly, if you want to add it to my queue, I have popped this. If it is not visited, I'm going to continue. Like if it is present in visited, I'm going to continue, or else I'm going to add it to my visited. I'm going to traverse on x comma y. If it is like I'm going to populate a new row and new column. So with this new column, I'm supposed to add it to my queue. So I'm going to say queue dot append of new row. So let me take Francis new column. So I have added this into a queue. And finally, you're going to print the answer, or else, sorry, this is the function that return the answer. So once again, if you see here, added 00 into a queue, we have taken a visited set while the queue is not empty. That means while the queue, you're going to take get row comma column, that is queue dot pop of 0. So if it is not visited, sorry, if it is visited, you're going to continue. If it is not visited, you're going to add 1 to your answer. Add the respective things into your queue. Yes, that means 00 is all added into a queue. You're going to traverse on X, you're going to get the particular direction. In this particular direction, you're going to add it to a queue. Further, for the next time, your queue is once again not empty, you're going to get the particular value. So only at this particular condition, so you're going to add it into a queue. But when you're while you're adding into a queue, so this extends and goes beyond the value that is given as the limit, something like minus 10 comma 10. So obviously it should be in this particular limit. If we do not have this particular condition, this goes in an infinite loop. So for this, what we're supposed to do, only if this minus 10, if it is less than or equals to new row, if it is less than or equals to 10, 10, and in the same way, new column also should follow the same condition. Minus 10 should be less than or equals to new call less than or equals to 10. 10. So only this particular condition I'm supposed to add this into my queue. Yes. So I got new row, new column. If it is in the range, I'm going to add it, or else I'm not going to do anything. Let us try to run it once. Okay, we got some output. Let us verify with the input and output. So 11, 21, 121, 123, and the entire input is same as in. Yes. Let us submit this. So we got correct answer. All the test cases got passed. Moving to the next problem, sum of modes. For binary string t, let f of t be the number of modes of string t. For example, f of 101 is going to be 1 as it has a unique mode 1, while f of 01 is going to be 2 as it has two modes with both 0 and 1. Okay, let us discuss about these modes. So firstly, you're going to binary string s of length n. To compute the value something like this. Okay, in very general sense, you're supposed to compute the modes of each and every substring of this given string S. Yes. Once again, you're given a binary string S of length n. You're supposed to compute the modes, the count of modes. You're supposed to return the count of modes of each and every substring of this particular binary string S. And discussing about this mode of a string is character with maximum frequency. If multiple characters have maximum frequency, all of them are said to be modes. For example, this 111 has a mode 1, while the string 10 is having two modes, that is going to be 0 as well as 1. Okay. Now the problem statement is clear. Let us discuss one example. So 0, 0, 0, 0, 1, 1, 1. Okay. So 0, 0, 1, 1. So for this particular binary string, we are supposed to compute the sum of modes of all the substrings. So what all substrings does it actually has? So 0 is one substring, 0, 1, sorry, 0, 0 is one is another substring, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 1, 1, 1, 1, and finally the last one. So that means we are done with 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 0, 1, Yes, we got all the substrings. Okay. So for this, what is a character with maximum frequency? That is 0. So we got a character with maximum frequency, that is only one character with maximum frequency. You're going to see the mode of this particular is going to be 1, and the character with maximum frequency here is going to be 0, and that is going to be two characters with maximum frequency, and these two characters are the same, and you're going to say 1 for this, 1 for this, and here once again you're going to say 1 for this. But here we got the maximum frequency of these two characters is going to be 2, as well as these two characters is going to be once again 2. So because of this, you're going to see the modes of this is going to be 2, and for this is going to be 1, for this is going to be 2, because this has occurred once and this has occurred once. And this is going to be 1, this is going to be 1, this is going to be 1, and then this is going to be 1. So the output here is going to be, so 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. So for this output should be 12. Let us verify with that. So this is the test case that we have taken, 0, 0, 1, 1. So second test case, yes, the output is going to be 12. Okay, so we got 12 as output. So what is actually making here? It is making very sense that if we can somehow generate all the substrings, if we can somehow generate all the substrings and call the functions, let us say we have some sum of modes function, or else we have calculate modes on this given substring function. You're going to call that particular substring in each and every, like for each and every substring. Yes, so this is one way of doing. But if you look at the constraints once, the value of n may go up to maximum of 10 power 5. So if it is 10 power 5, n square substrings are possible. If it is n square substrings, it is not possible to get our solution be accepted. So somehow we are supposed to eliminate this complexity. Yes, what else can we do? So firstly, calculating modes, I can simply say mode of the string s is going to be either 1, only two possibilities. I have only two possibilities for this. If you look here, we have only two possibilities. Either it is going to be 1, or else it is going to be 0. So either it is going to be 1, or else it is going to be 0. Sorry, my bad. It is going to be 1, or else it is going to be 2. So when it is going to be 1 and when it is going to be 2. So if you see here, count of number of zeros as well as count of number of ones are not equal in this particular substring, so it is going to be 1. In the same manner, count of number of zeros are going to be 2, count of number of ones is going to be only 1. So for this reason, the output is, the number of modes for this particular substring is 1. But if you look at this particular thing, count of number of zeros is going to be 2, as well as count of number of ones is going to be once again 2. So for this reason, the frequency of both the zeros and ones are equal. So for this, you're going to say mode is going to be 2. So it is going to be 1 when frequency of 1 is not equal with frequency of the substring 0, the character 0. When it is not equal, you're going to say this is this thing. Let us also take for this the exact same thing. If it is equal, frequency is equal. Yeah, so if you can somehow get the frequency of ones and zeros, that will be fine, right? So if you see here, the n square like n square substrings are which are possible, and for each and every substring, if you want to get the frequency, you also once again it's required to traverse on this particular substring. This once again take n time, or it is going to be n cube. N square is not submitting, but n cube, how can it be submitted? Yes, somehow we are able to submit. We should be able to submit. Yes, and if you look at some kind of logic here, if you see here, there are n square substrings in general, but actually these are not n square. That is going to be n into n plus 1 by 2, that everyone knows. In better sense, let us take an so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got overall 10 substrings for this length 4. Let us verify first. So as I said, n into n plus 1 by 2. So you're going to say 4 into 5 by 2, 2, you're going to say 10. Yes, we got 10 substrings. So for this, you're going to say 10 substrings which are possible. So for the each and every substring, if you see here, either the value is either 0 or else, sorry, the value is either 1 or else 2. Yes, the value is either 1 or else 2. That means 1 is definitely counted. 1 is definitely counted. And for this 2, if I can simply write 1 plus 1, and for this 2, if I can simply write 1 plus 1, if I can simply group all these things on base of substrings, how many substrings, like how many substrings I have 10 substrings, and for each and every substring I can simply add 1 to my answer. Yes, in total I'm going to get 10 as my answer until this particular part. And when I'm supposed to add one more thing for this particular thing, yes, when I'm having frequency of this particular character 1, if that is equal to frequency of the particular character 0. So if this is the sign, if this is the scene, I'm supposed to add 1 to this. So I have added 1 to this. Yeah, I'm going to add, like I'm done with this. I'm once again supposed to add 1 to this plus 1. With this I'm going to get 12 as my output. So this is the thing we are supposed to do. So that means it is making sense that firstly answer is going to be n into n plus 1 by 2. This is for sure. Yes, and later on you're going to add something to your answer. Yes, what is the thing that you're going to add to your answer? You're going to add one to your answer only if if frequency of 0, if that is equals to frequency of character 1 in the substring. Yes, in the substring. So this is the thing that you're going to do. So for this, you're not all required to iterate on all the substrings and check for frequency of each and every substring, because once again it will be the exact same complex like previous. Instead, we can simply do something like this. So if it is 0011, if it is 0011, we can simply assume, like we can simply balance this with something of this particular kind. We can simply assume this 0 as -1, this like 0 as -1 and 1 as 1, and we can simply try to populate some prefix sum, let us say prefix sum ps, and the very circuit is going to be 0. Yes, so when it is 0, what I'm supposed to do? I'm supposed to add -1 to my prefix sum. So it is going to be -1 here, and it is going to be -2 at this particular point, and it is going to be -1 once again. Let us take this 0, 0, 1, 1. Prefix sum is going to be, I'm not populating this prefix sum array, I'm just trying to perform this operation and just return the new value that I'm going to get here. So firstly, prefix sum, I'm going to get -1 here, because in the very start I'm having prefix sum is going to be 0. I'm going to get -1 here, -2 here, and once again when I get add -2 with 1, I'm going to get -1. So that means I'm for sure that I'm going to say there is a substring after this -1. There is a substring after this -1 which is balancing this one, which is having balanced number of ones and zeros. Yes. So after this -1, there is one substring which can balance the number of ones and as well as ones and zeros. So that is the substring that is 0 and 1. So for this 0 and 1, obviously we're supposed to increment our count. Yes. So when we got this -1, which is once again matching with this -1, which is already present, which is already taken in my prefix sum, can I just simply add 1 to my answer, saying that answer plus equals to 1 here at this particular point? Yes, and move further. And we want to make -2 here. When you're at -2, and once again -2 is already part of your answer, you're going to once again add it to your answer. Yes, in the same manner, if you can somehow extend this with 0 as well as 1, and this is going to be, or else 1 as well as 0, and this is going to be once again -1. So if it is -1 once again here, what you're going to add to your answer? What you're going to add? So even this is one possibility as well as this is one other possibility. From here to here, this is one other possibility. So instead of adding 1 to your answer, you're going to add 2 to your answer. Yes, so that means obviously you're supposed to keep track of the count of each and every time, then how many answers that we got. Yes, instead can we just simply use a hash map and store. If it is present, you can simply add it to a hash map. If it is if it is like if you found that particular name, you can simply increment the value that is present in your hash map. Okay. I hope the logic is clear. Let us try to convert this logic into code. Moving to this, exit full screen. Yeah. So let us say you are having for each and every test case, you are going to read this string as input, and you're going to call sum of modes function. Let us implement the sum of mode function here. Yes. So as I discussed, what is the first thing? What is the first thing? We can simply add this to our answer. Yes, we can simply add this to our answer. So as we're having these many number of substrings, so I'm going to say answer is going to be number of substrings. I can simply also take n value, can pass n value here, n comma s. So answer is going to be, so n multiply with n plus 1 by 2 row division. Yes. So answer is going to be n into n plus 1 by 2. That is for sure. Answer is going to be n into n plus 1 by 2. Yes. So after adding this to our answer, you're supposed to check how many number of substrings which are balanced. Yes. For each and every balanced substring, you're going to add one to your answer. How you're going to get? So firstly, you're going to take a hash map, something of this particular format. You're going to traverse on this particular substring, sorry, string. For let us say instead of indexes, you can simply traverse on each and every character. For I in S, if I. So firstly, as I mentioned, what is the prefix sum in the very start? That is going to be 0. So can I just simply say h of 0 is going to be 1? That means prefix sum of 0 is going to be 1. There is one thing that is having prefix sum of 0. If I in, yeah, so prefix sum is going to be 0. What I'm supposed to do? Firstly, I have to check whether this I is 0 or not. So if that is equals to 1, what I'm supposed to do? Prefix sum plus equals to 1. But what if it is 0? Else prefix sum minus equals to 1. So we got some prefix sum value. Yes. So with this prefix sum, I'm going to check whether this prefix sum is present in my hash map or not. If prefix sum in h, if it is present, what I'm supposed to do? Yes, answer plus equals to h of prefix sum. And after incrementing my answer, what is the next step? I also need to increment the value that is present in that hash map. So h of ps plus equals to 1. So we're done with this. So if it is not present, what if it is not present? If it is not present, we are supposed to make h of prefix sum is to be 1. Maybe this could be helpful for the future. So you're going to say h of ps is going to be 1. And finally, you're going to return the answer that you have got. Once again, go into this. We have to a hash map. You're going to say firstly the prefix sum with value 1 is going to be present. Prefix sum is initialized with 0 for I in S. If it is 1, you're going to say prefix sum plus equals to 1, or else you're going to subtract minus 1 from this. So if this particular prefix sum, if it is present, you're going to say answer plus equals to h of the prefix sum, and you're going to increment this prefix sum value that for the further references. And if it is not present, that means we are going to get this value for the first time. You're going to add it to your hash map and saying that h of ps is going to be 1. And finally, you got the answer. You're going to return this answer. Let us run this. We got some output. Let us verify with input and output. Yes, we got 4, 12, 21. So this is the same output for the input, exact same. Let us try to submit. Yeah, all the test cases got passed. Moving to the next problem, lexicographically maximal prefix and. You're given an array A of size n. You can rearrange the elements of A as you want. After that, construct an array B of size n. So that means you're given an array A of size n. You can rearrange this thing, and with this particular A, you're supposed to construct a new array that is B. And it was mentioned like B of 1, that is B of 0 is going to be A of 0 with 0th index. and b of I is going to be b of I minus 1 and with a of I. And if it is starting from 2, that means from first index to n minus 1 index, you're supposed to perform that operation saying that b of I is going to be b of I minus 1 and with a of I. So if I'm starting with 0th index, where and actually represents bitwise AND operator, yes. And out of all these, that means obviously multiple ways we can perform this. I can simply rearrange this, or else I can simply put the exact same, and I can simply generate, like without any operation on A, I can simply generate the value array B. This is also another possibility. But out of all the possibilities, I need to get the lexicographically largest possible array of B. So obviously lexicographical largest, if I want the array to be lexicographical of all the arrays, obviously the first value that you're going to take, the 0th element that you're going to take, that should be the maximum. Yes, and with the same constraint, the same will be applied for the first index and second index and the third index. Yes, move on in this particular manner. Okay, let us take an example 91114. So it is going to be 99114. So as we discussed, b of 0 should be equals to a of 0. The only thing I can do here, I can rearrange this entire thing. I can simply do like 9194 in this manner, or else in any manner I can simply rearrange this, something like in all permutations. And out of all this, I'm supposed to populate this something like b of I. B of 0 is going to be a of 0, and b of I is going to be b of I minus 1 and with a of I. So for all I is equals to 1 to n minus 1, b of I is going to be b of I minus 1 and with a of I. So this is the given logic that we are supposed to perform on this to get the array B, to populate the array B. And out of all the possible values, I need to populate the maximum possible lexicographically maximum. That is the lexicographically largest one that I need to populate. Yes. So what is the first thing that you're going to consider? So as it was discussed, b of 0 is going to be a of 0 for sure. So taking this into consideration as the first case, b of 0 is going to be a of 0. So nothing operation is being performed. So obviously if it should be the maximum, this first 0th index should be the maximum, and this 0th index, if it want to be maximum, what element that you're going to take? The maximum element of this entire array. So that means out of this entire array, what is the maximum element? That is going to be 9. You're going to take 9 as the maximum element of this entire array, with as the 0th element of the array B. Yes. So after this, if you want one more element to be once again maximum here, yes, if you want one more element to be once again maximum here, and this element which I'm going to get is performed by getting operation and between this b of I minus 1 with a of I. So b of I minus 1 which is already present, one element which is already present, and you're going to perform and operation here. And if you perform an operation, let us say a, let us say you're going to perform or else any and operation, what I need to mention, yeah. So if you're going to perform this and operation, a, let us say and with b, so obviously this and operation which you're going to perform, obviously after performing this operation will be always less than or equals to a, or less than or equals to b. Yes, this is for sure, right? Either it will be less than or equals to a, or else it will be less than or equals to b. It will not exceed a and b for sure, because if every value is same, it will be equals to a, or else it will be equals to b. Yes, as a and b are equal. If it is not equals to a, like a and b are, if they are not equal, obviously it will be less than or equals to a, and in more sense less than or equals to the smallest of the both. Yes, in this particular way. So obviously if I want the maximum here, maximum, with what I can get the maximum, with what in this entire array I can get the maximum with perform and with 9. Yes, if it is 9 once again, I can get the maximum, right? Yes. So I'm going to check whether 9 is present. Yes, 9 is present once again. I'm going to take it into my answer. Yes. So we are done with this. Moving to the next one. So I want once again maximum possible. So if I want maximum possible, let us try to take the binary representation from 9. That is going to be 1001. So if it is 1001, for any number, let us say a number, for any number, if it is having ones in this particular places, ones in this particular places, something else in this particular places, okay, I'm just concentrating only on this particular places, two places. If it is having ones in this particular places, does it actually make sense to get a maximum value? No, right? Obviously you're going to get a zero, that the value that you're going to perform, if these two are having like, if we do not consider this, if we do not consider this, yeah. So obviously this is not a better one. So obviously for this, anything it could be present here, doesn't matter. The only thing that we are supposed to consider is something like, if we want the maximum, either it could be one in this particular place, or and as well as one in the particular place. Yes, that means either one in this particular place, or else one in this particular place, or else one in both these particular places. Yes. So if I can simply check if there is possible value that is present, that is having one in this particular place, like, if I want to check to this particular place, that is going to be 8. Does 8 present in this? 8 is not present. Or else if you want to check for this, 4, sorry, 1, is 1 present? Yes, 1 is present. So with this I'm going to get 1, I'm going to take 1, and for the next time this b of I is going to be 1. I'm going to once again consider for 1, I'm going to take this one, that is going to be 0 0 0 1, and any operation you can perform with this, and you're not like, you're not having any element which is present in this entire array, and obviously you're going to take an element which is maximum, which is going to give you the 0, and so for this you're going to take the last as 4. Yes, and instead of populating this entire array with the elements which is 99114, you're supposed to populate with the AND operation with that, what you get. So AND operation with which you get as 9911, and finally when you perform AND with 4, you're going to get 0. So that is what we're going to do. So it is going to be 9911, and when you perform 1 with AND with 4, you're going to get 0. So this is going to be the final output that you're going to return. Yes. So this is the thing that you're supposed to do. In more sense, if I can simply think of the logic in more sense, let us say the A array is having elements, let us say 4 elements, let us say A1, A2, A3, A4. Okay, I need to somehow rearrange these elements, and after rearranging, let us say this is the rearranged one. So out of all this rearranged one, let us also assume this is the sorted manner. Let us say this is in sorted manner. This entire thing, let us say, in sorted manner. So obviously if it is sorted, what is the first element? Let us say in reversed manner also. Reversed manner. What is the first element that you're going to take? The maximum, which is present at 0th index. Let us say you're going to take A1. Yes. After taking A1, what is the next step? What is the next step? Obviously, you're going to take the next element, which is going to be A1, and with some other element. Yes, and with some other element. So as you have rearranged this and you have sorted something in different manner, you're going to take an element that is going to be some value, let us say A2, and with this value you're going to take for the, let us just assume this is the original format which are required. Okay, let us say you're going to say A1 and with A2, and you're going to perform the same operation with A3 once again. Yes, so this is the thing, this is the same thing that you're going to perform each and every time. Firstly you're going to take A1, you're going to multiply, like, and with A1 and A2, you're going to and with A1, A2 and A3, and this so on. In this particular manner you're going to populate this entire b array. I hope that is making sense. Okay, so that means if I can simply add A1, if you see here, A1 is present for each and everything. A1 is present, A1 is present, A1 is present. Obviously, A1 will be present. A1 is present for each and everything. If I can simply perform A1 for this entire thing for each and every time, will that actually help us? Okay, maybe it will actually help us. And for the next time, I'm going to get A1, A2. If I get A1, A2, what if I can simply add A1, A2 with this entire thing? So A1, A2, we're going to say A1 and with A2 and with A3. This is the first step, or else something like you're going to perform A1 and with A3 for the first time, and after later you're going to say A1 and with A2. This overall you're going to add with A1 and with A3, and you're going to get the same, because A1 and with A1 will be the same. So you're going to say A1 and with A2 and with A3. So this is what we are required, which we got at this particular point. Yes. So that means at each and every particular point, what if you can simply perform AND operation? Yes, that will be obviously going to help us. Okay, let us try to convert this logic into code. Let us try to exit the full screen. Okay, let us say you're going to take the input as lst. Let us say you're going to call the function lexicographically maximal prefix and you're going to print this result. Let us try to implement this function. So in the first step what I'm supposed to do, if you see here, as I'm supposed to populate this b, that is going to be a of 0 or else sorted manner zeroth element. Yes, in reversed manner. So firstly I need to sort this entire string, like entire list. Let us say lst dot sort. I'm going to sort this. This is not reverse sorted, this is general sorted. So if I'm sorting in this particular manner, let us also take the list that we are supposed to populate. B is going to be this. Okay, so what is the first element that we are going to add into your B? That is the last element of this lst, because this is sorted in reverse manner. So b dot append of lst of -1. So we have appended -1 lst of -1 into a b. So we are done with this. Yes. So after doing this, what else we are left over? So when we're done with this particular 9, do we need to once again consider this? So can I just simply eliminate this? Yes, I'm going to simply eliminate this. And once again, what I'm supposed to do, as I mentioned below, my current like LSC is going to be 9114. So 9114, and B is having the element 9 here. Yes. So what I'm going to do, I'm going to once again perform AND on this entire LST. I have eliminated the 9 here. So it is going to be, instead of 9114, it is going to be, at this particular point, it is going to be 9 and with 9, 1 and with 9, 1 and with 9, and 4 and with 9. And out of all this, what you're going to take? Maximum. If once again, if you want to take maximum, do we need to once again sort this? Yes. So we are trying to sort this operation multiple times. So instead of sorting it at the very beginning, what if you can simply write in some loop saying that while, so obviously you're going to remove the last element of lst each and every time. So at some particular point, this lst will be like becoming to the entire no elements. Yes, I'm going to say lst while lst, what I'm supposed to do, I'm supposed to sort this. So lst dot sort this. So after sorting, what is the next step? Okay, let me take the b array. B is going to be this. After sorting, what I'm supposed to do, b dot append the element that is going to be the last element, lst of -1. Yes, and supposed to remove the last element, lst dot pop. I'm going to remove the last element. After removing the last element, so if you see the logic, while the list is not empty, you're going to sort it. You're going to append the last element of b into this lst of I, and lst of, you're going to pop the last element. Yes. So after popping this last element, what I'm supposed to do, instead of this, let us just cut it and say what we're supposed to, maximal and, right? Mx and is going to be this. I'm going to append this mx and yes. So after performing this, what I'm supposed to do, I need to once again iterate on this entire list. So for I in range of length of this lst, what I'm supposed to do, lst of I, I'm supposed to replace this with lst of I and equals to max n. So once again, I'm performing AND operation with lst of I and with max n. So max n will be perform an AND operation with lst of I. Some value will be stored in this lst, and later on, once again, you're going to check while the list is not empty. You're going to say, you're going to sort this entire list, and you're going to take the maximum of all this. Yes, maximum. You're going to append into this max n. and finally you're going to return this array B. Yes, and if you see here, you're going to get this max and B is equals to append this max and you're going to pop this element. Yes, this is working fine. But at some particular point, this max and if some repetitions are present, so all the time if repetitions are present, you're going to perform the same operation. You're going to perform max and when you perform this operation, once again the operation will be the exact same because 9 and with 9 is going to give you 9 once again. So when it is 9 once again on always, like obviously you're knowing that you're supposed to take this 9. So at this particular point, do we need to sort it once again? Not at all required. So for this reason, what if you can simply say that after sorting it, if okay, after sorting and getting the max, and if I can simply say if LST of -1, if that is equals to max, and what I'm supposed to do, I need to perform this operation. But is this only just condition? Yes. Instead of maintaining a condition, I need to perform this operation for all the time which this max and is equals to list of I. So can I just simply say statements such that while a list of I, if it is equals to max and I'm going to append this max and to my B array and I'm going to pop this. So obviously when I'm popping this at some particular point, maybe this LST will reach the entire elements of the LST will be reduced and this LST may become empty array. So for this I'm also supposed to consider the case saying that while the LST, if it is not equals to this, or else length of LST, if it is not, it's like something like greater or equals to greater than 0. So if it is greater than 0 and LST of -1, if it is equals to max, and what I'm supposed to do, I'm supposed to pop it, sorry, I'm supposed to add it, pop it, and reiterate for all the, like pop it, add it, pop it all the time. And finally, you're going to iterate on the entire list, lst of I and with max and you're going to return this p. Let us try to run this. Yeah, we got some output. Let us verify with the input and output. The input is exact same 32011. Okay, we got the same. Let us submit. Yeah, all the test cases passed. Thank you for watching this video. For more content like this, please like, share, and subscribe to our YouTube channel. See you all in the next Smart Solution video.